in the flat plate collector, so we make use of air as a medium to get a heat collected so that we can transfer that heated air for any further applications. So here if you look at the diagram, so here the heat is a transport medium as I mentioned. So flat plate collector are used mainly for solar space heating. So this kind of flat plate collector, so where air collector are used for your space heating. It could be your buildings where your winter climates will be there. In that cases we can make use of this here to warm the area. So this in this the observer plates can be made up of a metal sheet. So there you can see some observer sheets here. I think the layer is not shown here. The observer sheet is not shown here. So in here the observer sheets are made up of a metal sheet and layer of screens or non-metallic materials. So this is how the observer plate will be made up of. It could be something like a steel or it could be something a non-metallic material. So the air which flows from the bottom part or from the side part, you can see here right now it is shown in the from the left side the air is entering. It will be like a hollow type. So entire flat plate collector will be hollow types. In between that we have a pipes. So that is a steel pipe. So here the air will be flowed naturally. So if not, we can make use of a fans also to blow the air within the flat plate collector. Since the air does not conduct heat easily as a liquid, so we can see some efficiency is very less in this air collector. So because if it is a water or any other liquid part, so heat can be transferred easily. Here the conduction is not so easy. So because it is open to the atmosphere and the space is more due to the outside climate condition, also the air will have a moisture content and it may soon as the air passes this will become cool. So hence the efficiency is very less as compared to the other thing. So once we go for there we will understand here. Here you can look at that the solar radiation will fall on the top of the that glass. So where we have a glazing, so to protect from the other physical damage they will be having something covered for that, and the plates are there. So it is given that it is not shown in a pipe way, they are given only plates, and there are fins, so where the air will pass within that fins. So apart from that the outer area it will be empty space and air inlet will be there and air outlet will be present here, and it has a insulation also because to protect the heat which is produced over there, because the efficiency is already less. If there is no insulation then the efficiency will drop further, so hence it will be provided with the insulation also. The second one here, it is a flat plate
Where
liquid
is it
collector.
used, sir?
Yes, pa? Liquid collector. So in this, the medium of the heat we are using as a liquid. It could be water, it could be your oil, or it could be something else fluid. So in general, we make use of a in domestic, or if you go for a commercial, we make use of a water. So here, this liquid flat plate collector heat liquid as it flows through the tubes. So where you can see there are tubes, fluid ducts we can see. So it is placed exactly on the observer plate. So where the heat, whenever the solar rays falls on that, it will absorb that heat and will give this heat to the metal which is flowing within the, sorry, the liquid which is flowing within the metal. And we have above once again the transparent cover. It could be once again glass or something transparent part where to protect from a mechanical damage. And below the observer we have an insulation once again, so where to protect your heat which is absorbed over there, it won't let the heat to go easily. So the efficiency is higher side compared to that one, because it is a fluid is a conducting heat and we have a insulation part and the casing which covers all this within a one case. So we have a casing over here. And here the simplest liquid as I mentioned, we make use of a water that heat and it passes directly through the solar collector. So that ducts will be the fluid duct will be connected with the larger diameter pipe at an inlet as well as the outlet. So where the water has to be enter, during that we have a larger diameter pipe where fluid can flow easily, and once it exits the hot water, so once again we have a larger diameter, we can store in the tanks also, like your solar water collector. And this mainly this kind of application used for solar pool heating. So solar pool, where swimming pools will be connected with this kind of solar pools, where the water will be continuously, we will be obtaining a hot water there. We can maintain a water temperature in a pool. So that is a one application here. But these collectors are typically unglazed. I am not using any glaze here. So we will discuss once again in detail what are the glaze materials are available. So in the coming topic we will discuss. In the previous case we had a glazing over there. In this we doesn't have any glazing. So what is the importance of glazing and what are types of glazing are there, we will discuss in detail in next topic. And here the liquid tubes can be welded. So whatever the fluid ducts we say is a liquid tubes also. So that can be welded to the observer plate also, so that the movement of this fluid ducts can be avoided. So that is also possible here. These liquid tubes are connected as I mentioned for any application. So most application in a domestic we use for a cooling system. So it is a solar pool heating system. So these are the two types of flat plate collector. One is air and one is liquid. We will discuss once again in detail about this part in the next topic. So the next one, I will go back here. So that is a concentrating collector. So there are two types. So right now it has been given only one here, one type of collector. So the other how it will be tracked we will explain here. Okay, we'll see. So this is my concentrating collector, or we say parabolic reflector also. So by looking at the diagram only we can assume that how the solar radiations are concentrated at one point. So there you can see the rays which is falling on this reflector, which has a entire the arch will be having a reflectors. Whenever the rays fall, it will directly reflect at one point. So where we have given a observing surface, so there we can have any water tank also, any metal devices. So with the observing surface, so that whatever the liquid or any thing which is present over there, okay, so that can be heated very easily. So this type of collector is called as a concentrating collector here. So in that I said two cases, one is stationary, one is tracking. Assume that this is a stationary. So I am not tracking any solar radiation. So in that case what happens, the angle of curvature will be very large. So right now you can see this parabolic reflector having a very large angle. So even though the sun moves from one direction to other direction, the rays can concentrate still on the parabolic reflector, so that I can observe that direction of the solar radiation. So it is possible without movement of this parabolic reflector. That is called as stationary. In a tracking mechanism, what happen? We connect something motors over there. It could be stepper motor or it could be servo motors. Why stepper motor, servo motor? Because they are very precise control with in terms of angle. I can rotate this entire dish. We say this arch as a dish also. So we can rotate this exactly with a precise angle, 10 degree, 20 degree, 15 degree based on the requirement. So that what happens during the sunrise, the direction of this parabolic dish will be towards the sun rising rays, and as the sun moves, the direction of the dish also will keep on move with the help of a motor. That is called as a tracking type collector. So these are the two types of collector which we come across in a concentrating collector. So the diagram for tracking is not given. They just said how to track that, how it will be vary as per the radiation of a solar. And here the comparison, when you compare these collectors, when you come back to these types of collector, if you try to compare the performance parameter, so we evaluate with two parameters. The first parameter is temperature range requirement for various range. So what is the temperature range required for various range or various application we can say. The second one, the second point which we try to evaluate in the comparison is collector concentrating ratio. We say CC ratio, collector concentrating ratio. So based on this, we try to determine how the comparison will be done here. So what is the CC ratio? It is defined as concentrating collector if the observer fin, so whatever the radiation which falls on the observer, then this observer fin's area will be AD. I will try to write here. This observer fin area AD is smaller than the observer area AA. Observer fin area AD is smaller than the observer area AA, and if the relative surface of such a reflector portion where we call as a CCR, so that is my A by AD. So this is called as a your collector concentration ratio. Based on this also we compare the different types of solar collector. And one more is a temperature range. So if suppose say the temperature is more than 40 to 60 degree, more than 40 to 60 degree, we accept this temperature for particular applications. So we categorize based on this temperature ranges also, whether it is a 30 to 80 degree or 50 to 200. So it may go behind 2000 degree also. So there are different types of collectors are there. So just I will list out the names and what is the temperature range and what is the CC ratio over there. And one more thing here, if the CC ratio is low, that is in between 2 or less than or equal to CCR is less than or equal to 5, we say it's a low concentration ratio. So if the range is between 2 less than or equal to 2 or less than or equal to 5, within this range we say it's a low concentration area. If it is greater than or equal to 10, if it is greater than or equal to 10, we say very high concentration ratio here. So here the different types of collectors are your flat plate collector, so where your CC ratio is 1 for that, and the temperature will range from 30 to 80 degree. Similarly, evacuated tube collector, so this we'll discuss in the next topic. So once again, where it will be like a vacuum tube, is nothing but evacuated tube is a vacuum tube, where it will be like a vacuum and the rod will be present, where we can make a surface such a way that the solar radiation fall exactly on the tube within the vacuum. So where temperature range from 50 to 200 degrees Celsius, and CC ratio is 1 here once again. And compound parabolic collector, so this once again CC will be 1 to 5, and temperature will range from 60 to 240 degree, and some etc. There are many things are given. I'll go with the last one, which is very important, heliostat field collector. So here your CC ratio is very high, that is 100 to 1500 CC ratio, and the temperature also will range from 150 degree to 2000 degree for very high temperature application. So basically we use this application for generation of electricity. So the heliostats are nothing but a mirrors. So where just I will try to draw a picture of that, a simple picture to understand. So where electricity will be produced, where we will be having a tower. So this kind of tower will be present, where in this tower the water will be present, and surrounding to this we place a mirrors like this, so which will be having a tracking mechanism. So this is a stand for the mirrors. So whenever the solar radiation falls like this, it will try to concentrate back on this tower, so that I can obtain very high temperature using this. These mirrors are called, so these mirrors are called say heliostat mirrors.